Next problem up, and let's handle it with that grace. So, first things first, read that question sentence. After how many hours from train A start will train B catch up to train A? So, this is a catch up problem. We are trying to catch up from one train to the other. So, my party people, let's write down the details here. Even if it seems familiar, I'm going to show you that not quite. So, here we go. We want to find out how much time it takes for train B to catch up to train A. However, everybody, we are basing this, and I'm going to highlight this here in green. We are basing this from the time that train A starts. Keep that in mind, okay? Right here, keep that one little detail in mind because we're going to start here with the top information. Two trains travel in the same direction. Everybody, really quick, when we think about trains traveling in the same direction or any pair of objects traveling in the same direction, what can we potentially do with those distances or rates? Yeah, potentially we can subtract. We can subtract to get that rate that they're moving apart at and the distance that they're apart. So with that, here we go. We see that train A starts at 60 miles an hour. So we have train A, the rate equals 60 miles per hour. Then it says train B starts 3 hours later. So I'll go ahead and say train B, 80 miles per hour for that rate. But I also see that train B started 3 hours later. Everybody, if train B starts 3 hours later, let's think about it. Train B starts 3 hours later. Let's multiply 60 times 3. What's that going to give us, my party people? Rate times time, 60 times 3. That's going to be 180 miles. Everybody, 180 miles is how far train A got for that head start. For that first 3 hours, train A traveled 180 miles. Now, at 180 miles apart, that's when train B starts. That's when train B starts trying to catch up. The question really is, how long does it actually take to catch up? How long will that take? So, everybody, let's take a look here. The distance that we're trying to catch up is 180 miles. Given that these two trains are moving in the same direction, what do we do again? I'm going to highlight it in green. What do we do again with that 80 and 60? We are going to subtract because, again, they're moving in the same direction. So 80 minus 60, that means that the second train, train B, is catching up at a rate of 20 miles per hour. It's catching up at that rate. Now we can find how much time it'll take. But be very careful, everybody, because when we lay this out, distance equals rate times time. 180 equals 20 times time. Be very careful because once we calculate this, divide by 20 on both sides, look at what happens. Cancels that out, and we get 180 divided by 20, which is 9 hours. Oh, look at that. Very tempting. Very tempting to pick A, right? Very tempting. However, everybody, the 9 hours is how long it took train B to catch up to train A after it started moving. After it started moving. Everybody, how long was train A already moving for before train B started catching up? 3 hours, right? Right here. Train B starts 3 hours later. So that's the one little detail that we have to blend in. 9 plus 3, that gives us 12 hours. That is the correct answer here. Answer choice C, because we have to add the 3 hours because we're saying this with respect to when train A starts. There's the 3 hours that train A is moving for, and then the time it takes to catch up. So that's why we have to add those together to get 12. But if you were close here, if you got 9 for this reason, that's still a very good try. But remember, the context is always more important than the calculation, but still, very good try. All right, next question. So we're going to look at the question sentence first per usual. So it says, how many complete boards can be cut? All right, sounds good. So again, the key word here, the key phrase is, how many complete boards can we cut? So everybody, before we even get into the actual information here, I want to just express and just discuss briefly what the word complete means when you're looking for a complete amount. What you're looking for is a whole number amount. So for example, everybody, let's say magically, I'm not going to use one of the answer choices. Let's say magically, we get our final answer and it says, oh yeah, it's going to be 14.95 boards. After we do all of our math, let's suppose that it says 14.95 boards. If that's what we had at the end, what would the answer actually be if we're only counting complete boards? What would it be in this specific case? 14.95, would that be respected as 15 or 14 as the final answer? Yeah, Angela, you got it right. That's going to be 14. Again, the word complete boards, it means, again, a whole number amount. So if you divide and you get 14.95, the answer would be 14. If you ended up getting 8.5, the answer is going to be 8 because we're only looking at the number of complete boards. So I just wanted to talk about that briefly before we get into the actual mathematics here. So let's go ahead and get into it. So from a 12-foot long log, a carpenter cuts boards that are 18 inches long. How many cuts can we make? Everybody, what operation does that make you think of? If I want to cut this 12-foot log and I want to make cuts that are 18 inches apiece and I want to see how many cuts I can make, that's division. Absolutely, 100%, that is division. So overall, what we're doing here is 12 feet. We are dividing 12 feet by 18. We are dividing it by 18 inches. And so we can't divide quite yet, because if we're dividing the same dimension, distance, we have to have the same unit. So it's 12 feet divided by 18 inches. Well, we're going to have to either turn the feet into inches and then divide, or turn the inches into feet and then divide. Either way, you'll have the correct answer. So I'm going to choose to go with keeping the numbers as whole numbers. 12 feet is the easier one to deal with, but you can go with both. But I'm going to choose to convert the 12 feet into inches. 1 foot equals 12 inches. So we will be multiplying in this specific case. So we'll do 12 multiplied by 12, because every foot is 12 inches. You have 12 feet. 12 times 12 gives us 144 inches. So we have 144 inches divided by 18 inches, and that's going to give us that final answer. So again, the way that we got here, one more time before we do the calculation, the way that we got here was we knew that we had one big log, and we wanted to make as many cuts as we could to make boards. Every cut represented one board. And so when you're trying to figure out how many times you can cut something, how many times you can subtract, that is division. So boom, there we are. 144 divided by 18. We can show that as long division over here, but it's really no point because 18 doesn't go into 1, doesn't go into 14. And so we have to take a guess here to get to 144. And so this is where I'll reveal the correct answer. It's going to be 8, because after some guesswork, some guessing and checking, we could get 18 times 8. 8 times 8 is 64. And then 1 times 8 is 8. Carry the 6 is 14, getting us to that 144 that we're trying to divide into. So the answer there would be 8 complete boards that we would be able to make. The correct answer is B, 8.